So now we've seen the roadmap, we've balanced equations. Let's include those equations in the roadmap. We'll start off with some simple ones and move in to do quite a few examples of the so-called gram to gram conversion. Starting off, that's the roadmap. See what we've got. Titanium oxide reacts with bromine trifluoride to form titanium fluoride, bromine oxygen, as shown in the equation. There's the equation. How many moles of bromine trifluoride, so that's what we're asked for, needed to react with 4.84 moles titanium oxide. That's what we're told. So the A side is going to be titanium oxide, and we're given the moles, so therefore nice blue arrow pops in for the moles there. We're asked about bromine trifluoride, so that defines what's on the B side. And again, what are we asked for is the moles right there. So nice, straightforward, one-step question. Pull out the salient bits. Go from moles to moles. We use this ratio relationship here, moles of B over moles of A as the coefficient of B over the coefficient of A. These coefficients almost always coming from a balanced chemical equation. Let's throw in what we know. We don't know moles of B, that's the BRF3. We do know the moles of A, that's the TiO2, was 4.84 moles. Coefficient of B, the BRF3, from the equation is 4. Coefficient of A, that's the TiO2, from the equation is 3. So that goes in there. Multiply it out, 6.45 moles of BRF3. Reaction between Na2O and P4O10 forms Na3PO4. So there's our nice little roadmap. Let's see what goes on. How many grams of Na3PO4, so that is what we're asked for, will be produced from a reaction of 0.2 moles of Na2O. So Na2O is our A substance, and we're told the moles of that, 0.2 moles. We're asked about Na3PO4, so that defines the B side. And what are we asked about Na3PO4? The grams. So this is a two-step. We go from moles of A to moles of B in step 1, and then moles of B to grams of B in step 2. Pulling out the important bits. Step 1 is the mole to mole conversion. So moles of B, which is the moles of Na3PO4, to moles of A, which is the moles of Na2O, is the ratio of the coefficients. Now from whence those coefficients come? And the answer is balanced equation, which we don't have. We are told, however, enough to get that balanced equation. Reaction between Na2O and P4O10 forms Na3PO4. So there we are. Na2O plus P4O10 goes to Na3PO4. Obviously, we've got imbalance of everything. I would start off by saying, well, phosphorus is nice and easy. 4 here, 1 here. So obviously, to get the right number of phosphoruses, I need 4 Na3PO4s. Again, oxygen's a bit sneaky, but let's use the sodiums. 4 times 3, 12 sodiums here, which means we need 12 sodiums over here. So every Na2O has 2 of them, so therefore to get 12 we need 6 Na2Os. Check the oxygens, 6 plus 10, 4 plus 4 is 16, so nicely balanced. So moles of B, Na3PO4 don't know. Moles of A is going to be 0.2 moles. Coefficient of Na3PO4 is 4. Coefficient of A, the Na2O, is 6. Pop all that in, and there they are. Multiply it out. And we get that we have 0.133 moles of Na3PO4. So this box here, 0.133. Step number 2 now, the very familiar conversion between moles and grams. Grams is moles times molar mass. Throw everything in. Moles was 0.133. That's this box here from the calculation we did in step 1. Molar mass of Na3PO4. Again, I'm not going to dwell on these, but you can see where all that comes from. And that gives us a total of 21.9 grams. Continuing on, how many grams of aluminium chloride can one obtain from 6 moles of barium chloride according to that nice equation there? So roadmap. What are we told about? We're told about barium chloride, which is BaCl2, so that's substance A, and we're told the moles of it, so that's right there, that's our starting position. We're asked about aluminium chloride, so that defines this as the B side. Aluminium chloride, obviously AlCl3, if you didn't know it straight off the top of your head. And what are we asked for of that? The grams, so nice little arrow there. So again, a two-step. starting off with the moles of one substance going to moles of the next, and in the second step moles to grams. Familiar stuff again, pulling everything out. Step 1, we need the ratio of the coefficients. We do in this case have the balanced equation. So moles of B, AlCl3, moles of A is the 6 moles of barium chloride. Coefficient of AlCl3 is 2. Coefficient of BaCl2 is 3. Pop all that in. There's the 6, there's the 2, there's the 3. Moles of aluminium chloride is 4. So this box is 4 moles. Step 2, going from the moles to the grams. Again, familiar relationship. Grams is moles times molar mass. We got the 4 moles of AlCl3 from above. Molar mass of AlCl3 right there. 534 grams. So now we're going to do several examples of the classic stoichiometry question, which is a grams to grams. So according to this equation here, starting off nice and simple, hard to give you an easier equation than this one. What mass of CO2 will 15 grams of carbon produce? So what do we know? Carbon, and we know the grams. What are we asked for? CO2, and we're asked for the grams. So step 1, grams to moles. Step 2, moles to moles. Step 3, moles 2 grams. A nice little mantra that, like I say, is the standard stoichiometry type of question, mainly because it's the one that makes most sense. You weigh out your grams, so that's what you're starting with, and usually you want to know what mass you've made at the end, so grams to grams. Step 1, the usual. I'm going from our grams to our moles using that same relationship there. We know grams is moles times 12 molar mass of carbon, so we got 1.25 moles. Moles to moles in step 2 using the hopefully now familiar ratio setup. So moles of CO2 over the moles of carbon, which is 1.25, and in this particular equation here, 1 to 1, can't be nicer than that. So 1.25 moles of CO2, and then of course finally moles of CO2 to grams of CO2, 55 grams. Getting a little bit more complicated here. Lead 2 sulfide used in glazing earthenware gives a poo. It will also react with hydrogen peroxide to form lead sulfate and water. How many grams of hydrogen peroxide needed to react with? 53 grams lead 2 sulfide. So we know about lead 2 sulfide and we know the grams. We're asked about hydrogen peroxide, H2O2, and again it's the grams. So again you see grams to moles, moles to moles, moles to grams. Step 1, grams to moles. So the molar mass of lead sulfide, 207.2 plus 32. So we got 0.222 moles. Step 2, we of course now need the coefficients of a balanced chemical equation. So here's the balanced chemical equation for you right here. PbS plus 4H2O2 goes to PbSO4 plus 4H2O. As promised earlier, I'm not going to balance the things step by step. You can work out how to do it quite easily yourself. But anyway, so the ratios there, H2O2 is 4, PbS ratio is 1, so 4 to 1, and so we have 0.888 moles H2O2. Finally, convert that to grams, and we get 30.2 grams. Hopefully not going too fast for you. By this stage, the steps should be very familiar. Now it's more just a question of, if you didn't get the right answer, us working it through, giving you the values step by step so you can catch your mistake. So we'll do another one just for fun. So 11.6 grams of iron nitrate is what we're told about, and we're asked for the mass of iron 3 sulfide, Fe2S3 right there. And so again, grams to moles, moles to moles, moles to grams. So step 1, the familiar grams is moles times molar mass. Make sure you get the right molar mass for these complicated formulas. We've got 1 iron, 55.85. Nitrate is 14 plus 3 times 16, and of course multiplied by 3. Pop everything in, gives us 0.048 moles of the FeNO3. That's this box here. Step 2, in order to go from moles of one thing to moles of another, we need their relationship with the coefficients of the balanced chemical equation, which is right there. Again, I'm not going to do it for you, but it's a relatively straightforward one. You've got the 2 ions to the ions here, so that gives you 2 there. You've got 3 sulfurs, so you have to have 3 of those. That then gives you the appropriate number of sodiums, 6 there and 6 there. Or you could, of course, have just used the 3 nitrogens there, times 2 is 6, giving you 6 nitrogens there. Lots of ways to balance it. A fairly straightforward one, so I'm not going to waste any more time than I already have on it. Anyway, so the coefficient then, Fe2S3, the coefficient is 1. Coefficient of FeNO3 3 times is 2. Pop all those in, there's the 1, there's the 2, and that means we have 0.024 moles of the Fe2S3. Step 3, multiply that by the rather large molar mass, not too tough, 2 ions and 3 sulfurs, and we end up with 4.98 grams of the Fe2S3.